Okay. So anything you say it loudly so that the computer can pick it up.
Okay.
All right, so we're going to talk about combining functions. So we're going to be given two functions, f of x and g of x. Just in general, it could be f of x and g of x. It could be anything, but for the purposes of today's lesson, I'm going to use f of x and g of x in the notation. So, adding and subtracting two functions. So, the notation for this. So over here we're going to write notation. All right, and the notation looks, you'll see this. You'll see f plus g of x. Like that. That's what you're going to see. Okay? And really what that means is we're simply going to take f of x and add, plus g of x. And the domain for this new combined function is going to be where the two domains overlap. All right? So f of x and g of x, it's f plus g of x, the domain. It's going to be where the two domains overlap. Okay. So the new domain will be where the two f of x and g of x, where they both exist, right? Where they overlap. So on this side, we're going to do our example. F plus g of x. How do I write that? What is f plus g? Correct. X plus 6 plus 3x squared, not cubed, squared. All right, what about subtraction? So for subtraction, everything stays the same except you'll see f minus g of x, and then it'll be f of x minus g of x. All right? Just make sure to put that g of x into parentheses. And the domain will still be where the two domains overlap. So for our example, f minus g of x will be what? X plus 6 minus g of x, which is 3x squared. Okay, so I don't have very far to distribute that negative sign, so I actually don't need that negative sign. But if g of x were anything more than just one term, I'd need to remember to distribute that negative sign in. Does that make sense? That's something that is easily forgotten. So it's just x plus 6 minus 3x squared. What is the domain for both of these new functions? Do I have any restrictions on x for f of x? No, what's the domain of x plus 6? Yes, that's correct, Tom. Negative infinity to positive infinity. What's the domain for 3x squared? Negative infinity to positive infinity. So where do those overlap? Negative everywhere, right? Negative infinity to positive infinity. So the domain for both of these new functions is negative infinity to positive infinity. Right? And that's for both f plus g of x and f minus g of x. All right, does that seem fairly straightforward to you guys? Yes, Carlos. The domain restrictions, remember domain restrictions are values in which something can occur, right? So the only domain restrictions that we've worked with so far is remember that if I have f of x equals the square root of x, that this, whatever's under the radical has to be bigger than or equal to 0. So the domain for this is that x has to be greater than or equal to 0. So 0 to positive infinity, all right? So if it were more than just x under there, I'd have to take that stuff and say that stuff under here has to be bigger than or equal to 0, all right? So that's one domain restriction. The other domain restriction we see with f of x equals 1 over x or 1 over x squared. What do we know about that function? Yeah, x can't be 0, right? So the domain is all real numbers except x cannot equal 0. And x is really, remember, a placeholder. Anything in the denominator. If it were x minus 10, x minus 10 itself can't be 0, meaning that x wouldn't be able to be 10. Does that make sense? So those are the only times we need to worry about having a domain restriction. Okay? All right, so let's talk about multiplying functions. All right, again, notation. The notation, it looks like this. F, usually they put a little dot, sometimes they don't. F times g of x, or sometimes you'll just see f, g, and then an x. You might see that. Okay. And that's literally just f of x times g of x. And again, the new domain will just be where the two domains overlap still, okay? All right, so for example, what is f times g of x? Yeah, so make sure to put it in parentheses because we're going to have to use the distributive property. Does that make sense to everyone? Okay. So that is then what? Yeah, 3x cubed plus 18, 18x squared. Excellent. All right, and remember that multiplication is commutative, so this and g times f of x will be exactly the same thing. Okay. Addition is commutative as well, so f plus g is going to be the same thing as g plus f. The only one that you have to be careful of is f minus g is not the same as g minus f. Okay. Anyway, what's the new domain? It is negative infinity to positive infinity. Okay. Now let's talk about dividing. Okay? Yes, sir. Nothing. Mm-hmm. Is that not what I have? Oh, this 18 just looks flattened. Mm-hmm. Yeah, that's an 18. All right, so dividing. So the notation for dividing is you'll usually see f over g of x like that. And that literally means f of x divided by g of x. Remember that long bar there? That is division. F of x divided by g of x, or f of x times the reciprocal of g of x. Right? Now, the domain is still the overlap with one additional consideration. What is that one additional consideration going to be? G of x can't be 0. So the domain is still overlap, except g of x cannot equal 0. So you have to figure out what x's would make the denominator 0, right? And exclude those from the domain. So again, this is not commutative. F divided by g of x is not the same as g divided by f of x. So for our example, f divided by g of x is what? Yes, x plus 6 over 3x squared. And what's the domain? Exactly, so good. Negative infinity up to 0, or 0 to positive infinity. That's the domain, sorry. Think about what would make the denominator 0. Only 0, yeah. So just in my head, what I did is I said, what values make this happen? Well, x squared equaling 0, because the 3 doesn't make any difference. So x is 0. So that's a domain restriction. Does that make sense? Set the denominator equal to 0 and figure out what values make it 0. All right. So the last one is maybe the harder one. It's not too hard. The notation looks confusing. The notation looks a little bit like fog. It's composition. F composed with G of X. But this is like a little circle. It should be smaller than the G. So it's an open circle. So you have to be careful. This is different from the multiplication. The multiplication is a filled in dot. This one is an open dot. Okay? And this is F composed with G of X. F composed with G of X. And what it means is you take F, but in place of the X's, you put G of X. So sometimes you see this written. That's F composed with G of X. Now it is not the same as G composed with F of X. And it's not multiplication. Okay, so don't multiply them. Okay. The domain is a little tricky. The domain, I would say, consider G of X's domain first. Okay, so first look at G of X's domain, then look at the domain of the final. All right, and where the domain of the final overlaps with G of X, that's your domain. Yes, Alex.
So when you're solving it, would it just be f times?
It's not times.
No, like f of 3x squared.
Yes, that's exactly what it is. Yes. All right, so it's the overlap between G of X's domain and like the domain of your final answer. Does that make sense? So consider G of X's domain first, then look at F, that's a composed with. f composed with g of x's domain. Where those two overlap, that will be the domain for the composition. So let's do f composed with g of x for this example. So this is f of x with, instead of x's, you write g of x. So Alex pointed out it might be easier to write this as f of 3x squared. Yeah. So that means this stuff plus 6, right? This is f of x, right? F of x says something plus 6, right? Think, yeah, and it's going to be 3x squared. So I don't really need those parentheses, but I make a lot of mistakes when I'm doing composition of functions. I forget the rest of the original function sometimes. So what I do is I write out that outside function first with parentheses every place I see an x, and then I fill in after I do that. So what is g composed with f of x? So this one's different. What is this one? So what I do is g of x is the outside, so I do 3 times something squared, right? I rewrite g of x without x's, and I put x plus 6 in, yep. Okay? So it's that, or that would work out to be 3x squared plus, it would be 12 times 3, which is 36x, and then 6 times 6 is 36 times 3 is it 108?
36 times 3.
Yeah, 36 times 3, 108. All right. What is the domain for both of those? Have there been any domain restrictions on g of x? Is there any domain restriction for g of x? No, it's all real numbers. Is there any domain restriction on 3x squared plus 6? No. So the domain for both of these functions, because f of x's domain is also negative to positive infinity, so both of these, the domain is negative to positive infinity again. Okay? Does that make sense?